L2. We have been hearing this a lot since James Webb Space Telescope is in news. NASA's prestigious space telescope, an engineering marvel, reached Sun Earth L2 or the Lagrange Point 2 on 24th of January this year. It will unravel the secrets of the early universe just 300 million years old after the Big Bang. On 12th December 2020, a near-Earth object called 2020 XL5 has been discovered orbiting Sun Earth L4 by Pan-STAR-1 survey at Haleakala Observatory, Hawaii. Also, the Indian Space Research Organization is planning to launch its ambitious solar observatory Aditya L1 to Lagrange Point 1 to study the Earth's atmosphere in the third quarter of this year. So, what are these Lagrange points? How many such points are there? Are there any other spacecrafts in those regions? These are the questions we like to fly by through this capsule video. Take any two massive objects orbiting each other like Sun and Earth, Earth and Moon, Sun and Mars, Sun and Jupiter, and so on. They orbit each other due to the gravitational force between them. If an infinitesimally small object comes in their mutual gravitational influence, it will get hurled away by the centrifugal force acting on it. But if it is in a point where the centrifugal force becomes equal to the combined gravitational pull by the massive objects on it, it will stay at that point. The object in that point will be in equilibrium. Its orbital period will be same as that of the lesser massive object. If we take Sun-Earth system, these points will move with the orbital period of Earth. There are 5 such points in the vicinity of two massive objects. Those points are called Lagrange points L1, L2, L3, L4 and L5. We can literally park a spacecraft in those points without the consumption of fuel. These points are named after the Italian mathematician and astronomer Joseph Louis Lagrange. While he was working on the three-body problem, he found out two of these points, L4 and L5. Later, Leonhard Euler discovered L1, L2 and L3. Now let's see where these points are exactly located. Let's take Sun-Earth system here. L1 lies in the line joining between Sun and Earth. L1 of the Sun-Earth system lies approximately 1.5 million kilometers from Earth towards the Sun. L1 is one of the main Lagrange points of interest for space missions. As this point is closer to Sun, it is a wonderful place to insert solar observatory. ESA and NASA's joint project Solar and Heliospheric Observatory aka SOHO is in L1. It is observing Sun since 1996. It has already discovered over 4,000 comets. If the object is closer to Sun than L1, it will orbit around the Sun in the heliocentric orbit and will have an orbital period less than that of Earth's. L2 also lies in the line joining of the two objects but beyond the lighter member of the pair. It is another point of interest for space missions as it is farther away from the Sun and keeps the probe cooler. It's an excellent point for observing the universe in low-frequency radiations. L2 of Sun-Earth system lies 1.5 million kilometers in line on the far side of the Earth. NASA's Wilkinson Microwave Anisotropy Probe aka WMAP was in L2. It studied the properties of the universe in cosmic microwave background or CMBs, which is the remnant of early stage of the universe and the Big Bang. If the object is slightly farther than L2, it moves with an orbital period greater than Earth's around the Sun. The third Lagrange point L3 lies beyond the massive object of the system. L3 lies a little outside the orbit of the Earth on the far side of the Sun. As it always lies behind the Sun, currently it is of no use for space missions and it is most unlikely. Lagrange points L4 and L5 lies along the orbit of the less massive object in a way that the Lagrange point and the centers of the two massive objects will make vertices of an equilateral triangle. In the orbit, point L4 moves ahead of the Earth and L5 behind the Earth. Equilibrium is a generalized concept. A body can be in stable, unstable, or neutral equilibrium depending on its physical surroundings. The Lagrange points L1, L2, and L3 are in unstable equilibrium. An object on these regions will be like a ball sitting on a smooth spherical surface. A small disturbance can kick the ball out of its position. In space, a small perturbations like the tug of an asteroid can dislodge the space probe. In order to keep the spacecraft in the orbit around the Lagrange points, we have to provide a thrust which is called orbital maneuvering. For that reason, there is a less chance of finding a natural object in these Lagrange points. This feature makes L1, L2 and L3 excellent points as parking stations for telescopes and other space probes. On the other hand, L4 and L5 are stable equilibrium points. An object in these points will be like a ball inside a hemispherical bowl. Once inserted, it can remain there forever unless a strong external force dislodges it. This makes it a collecting point for many natural objects. What you see here is the L4 and L5 of Sun-Jupiter system where there are plenty of asteroids called Jupiter Trojans. They are called Greek camp at L4 and Trojan camp at L5. There are also Venus Trojans in Sun-Venus systems L4 and L5. Likewise, natural objects like minor planets, centaurs, natural satellites, etc. can also be found on all the L4s and L5s in our solar system. Apart from 2020 XL5, as I mentioned earlier, another object in Sun Earth L4 is an asteroid called 2010 TK7. These objects are called Earth Trojans. In the Lagrange points L4 and L5 of Earth and Moon, there exists a large concentration of dust called Kordylewski clouds, named after the Polish astronomer who first reported the presence of these clouds. There are many probes which were and currently are and will be inserted in Lagrange points. Let's have a look at some of it. Lagrange points, especially L4 and L5, is a proposed form of space colonization. In 1974, American physicist and space activist Gerald K. O'Neill proposed the possibility of space colonies in L5 of Earth-Moon system. He argued that it could fit thousands of floating colonies. As natural disasters like Chicxulub impact could wipe out our entire species, space colonization is an excellent idea. For the long-term survival of our species, it's important to dig up habitable places in the universe. Thanks for watching. See you again in the next video.